Hey guys, welcome to the 9th episode of GCSE Maths. Today we're going to be doing some completing the square. This is quite a further ahead topic, so it's a one-off video. We'll go back to some more algebra later. So, let's get into it. So, let's start by solving quadratics by completing the square. First, we need to learn how to factorize it into the form of a complete square. So first, you want to rearrange the quadratic into the standard form, so ax squared plus bx plus c. In case you don't know, a, b and c are all coefficients. C not really, c is a constant. So a is, let's say if it was 2x squared, a is 2. If b was 5, it would be 5x. Yeah. Then, what we want to do is, we want to find the root of x. In this case, it's in all cases really of a quadratic, it's an x. So you have x, and then you want to have half of b. So then when it's squared, when the whole bracket is squared, so x plus b over 2 whole squared, b over 2 becomes bx. If you get what I mean, because whenever it's a plus b whole squared, it becomes a plus 2b plus b squared. So we'd have x plus b over 2 plus b plus 2b plus b over plus 2bx plus b over 2 whole squared. Sorry if that confused you guys a bit, but yeah, that's the essence of it. Then what you want to do is you want to multiply out those brackets. So you want to multiply out x plus b over 2 whole squared, and then you compare the two, and then figure out if you have to subtract an adjusting number from it or to add it, as it says there. So, here's an example. So, the question is that you need to express the quadratic x squared plus 8x plus 5 in the form x plus m whole squared plus n. So, what we want to do is, since it's already in the standard form, we don't have to rearrange at all. So we can start off with completing the square. So we have x, because it's the root of x squared, and then we want to have half of b, which is 4, since b is 8. So after we do that, we multiply out the brackets, and we will compare to the original. So x plus 4 whole squared is equal to x plus 8x plus 16. So the original equation had 5 instead. So we know that we need to minus some from this complete square. So what we want to do is to minus the 11. So we subtract the adjusting number. And the adjusting number is 11. So we have x plus 4 whole squared minus 11, which is equal to x squared plus 8x plus 16 minus 11, which is x squared plus 8x plus 5. So we're back to our original equation. Therefore, the completed square is x plus 4 whole squared minus 11. So that's just an easy example to get us started. Now, we're going to figure out how to solve it. So the second question is, hence, using our completed square, solve x squared plus 8x plus 5 is equal to 0, leaving your answers in set form. Of course, you could have used normal quadratics, but instead, what we're going to do here is use our previous equation. So we have x squared, x plus 4 whole squared, minus 11 is equal to 0. Then, we can add 11 to both sides. So we have x plus 4 whole squared on one side, which is equal to 11 on the other. So now, what we want to do is we want to get rid of that. Indices, the 2. So we want to square root both sides. So it becomes x plus 4 is equal to plus or minus root 11. Make sure to include the plus or minus, so then it encompasses both roots of x. Next, this is a simple equation because we can find out x straight away. And therefore, you just need a minus 4 from both sides. So that comes out to be x is equal to minus 4 plus or minus root 11. So we add the plus or minus, then there are two solutions. X is equal to minus 4 plus root 11, and x is equal to minus 4 minus the root of 11. So that method was just if a was 1. So there's no a, basically, because you don't need to write it down. So what happens if a is not 1? Well, let's see. So everything is the same. It's just that you have to take a factor of a out. And that can lead, before you start, which can end up with awkward fractions. So this time, the number in the brackets is b over 2a. Okay, let's see an example. That might make it a bit easier to explain. So the question here is to write 2x squared plus 5x plus 9 in the form a times x plus m whole squared plus n. So it's just asking us to complete the square when a is more than 1. So it's already in the standard format, so we don't have to change a thing about that. But now that we have the coefficient of the coefficient a is greater than 1, well, isn't 1 really, we have to take a out of the brackets. So instead, what it becomes is we factor out the 2 because a is 2, and inside the brackets, all that we have left is x squared plus 5 over 2x, because we half the 5 due to the 2 coming out. Then we bracket off, and then plus 9 because that's the constant. So let's remove the plus 9 for now. Forget about it. So instead, what we have is 2, and then we want to complete the square. So 2. Then in brackets, this is the completing the square part, x plus 5 over 4 whole squared. So you notice that we turned from 5 over 2x to 5 over 4. Well, that's the same reason as before, because we halved the coefficient b. So b of 5 over 2 divided by 2 is 5 over 4. And we took the root of x. So x plus 5 over 4 whole squared times 2. So and if we multiply that all out, it becomes 2x squared plus 5x plus 25 over 8. So we've got the first two numbers correct, so the 2x squared plus 5x, we've got that. But the 25 over 8 is still there. And the original equation had 9. So to get 9 over here, we want to to get the 9 over here, we want to add 9. Sorry guys. You want to have 9 minus the 25 over 8, which equals 47 over 8. So the 2 and x plus 5 over 4 whole squared plus 47 over 8. Since the difference of 9 and the 25 over 8 is 47 over 8. So now, let's put that all together. 2x squared plus 5x plus 25 over 8 plus 47 over 8. Because we have to add more to get to 9. So therefore, it becomes 2x squared plus 5x plus 9. Which is the same as the equation from before. So now we can confirm that the completed square is 2 x plus 5 over 4 whole squared. So x plus 5 over 4 whole squared times 2 plus 47 over 8. If that was a bit confusing, then pause here just so you can really understand the example and see what it's doing there. Okay, let's continue. So, you may be asking, how does this come into use in more real senses? So, my answer to that would be, let's say you're looking at a graph. You want to predict what the highest point is and what the minimum point is. And, well, you can do that if you have the formula, using completing the square. It can help us sketch a graph to be around it. So, let's see how this works. So, there are main rules to know how to sketch a graph using completing the square. So, if it's a positive quadratic, so the coefficient a is positive, The adjusting number tells you the minimum y value of the graph. The adjusting value is the thing that we changed. So, and if the completed square is a times x plus m whole squared plus n, the minimum y value will occur when the brackets are equal to 0, because the bit in brackets is squared, so it's never negative. Remember, this is only when a is positive. So that means that when x is equal to minus m. Then, let's see. The second thing that we need to know is that the solutions to the equation tell you where the graph crosses the x-axis, so the x-intercepts. And the last rule is that if the adjusting number is positive, the graph will never cross the x-axis, as it will always be greater than 0. So this means that the quadratic has no real roots. Let's now look at an example of graph. So, we want to sketch the graph of y is equal to 2x squared plus 5x plus 9. So, the completed square form, you could do this in your book or notepad. You could try it out for yourself to practice completing the square. But once you've got that, you'll know you're right. It'll be right if the answer is 2 times x plus 5 over 4 whole squared plus 47 over 8. Well, really, we're just using the answer from before, but it's fine. Then, so we know the minimum point occurs when the brackets are equal to 0. So this will only happen when x is equal to minus 5 over 4, because 5 over 4 minus 5 over 4 is 0. The 2 isn't really that relevant here because 0 times 2 is still 0. So at this point, when x is equal to minus 5 over 4, the graph takes its minimum value, which is the adjusting number, 47 over 8, as I said before. Since the adjusting number is positive, the graph will never cross the x-axis. So it'll be think of it this way, it'll be a happy graph. So the minimum point will be down, and the parabola would just go up. And if you want to find where the curve crosses the y-axis, you can substitute x in, which is 0. So if we do that, then y is equal to 0 plus 9, which is equal to 9. So just the constant is really where the y-axis is, where our y-axis, the y-intercept, occurs. So using that, we could sketch a nice graph, which, even though it may not be really like the graph as shown before, it's good enough for us to really understand and grasp the main properties of a graph. So that's the end of this video. Thank you guys for watching. Make sure to like and subscribe if you found this fun and if it helped you quite a bit. Make sure to put any questions in the comments or any comments in the comments. And thanks guys.